Greetings, welcome to Lab 2 Part 2, working with normal distributions, but this time we're going to talk about the z-score. So in this exercise, we're actually going to be doing exercise 3.3. We're predominantly going to be talking about the z-score. So a quick review of what the z-score is all about. The z-score of an observation is the number of standard deviation that falls above or below the mean. We compute the z-score for an observation x that follows a distribution with mean mu and standard deviation using the following formula. Now, there are very few things in this class that you're going to be asked to memorize, but this is one of them. You're going to need to make sure you've got this one top of the head, okay? So in your comp book, yes, very important, put that in your reference book, but you should also have this top of the head, okay? So a couple of things just to make sure you understand what it's actually doing here with this particular formula is that notice what you're doing is you're taking your data point or your observed data value. That's this value right here. That's your observed data point, and what you're doing is you're subtracting the mean from it and then dividing it by the standard deviation. Okay, so let's open up a fresh whiteboard real quick and let me show you what that would look like. Okay, so what that means is this. If we were to draw ourselves a number line here and we put on the number line here mu, and then we say over here this is the value of x, then the distance between those two values can be calculated to be x minus mu. In other words, the distance from there to there is x minus mu. And so then what we ask ourselves is we want to know is, looking in this interval between here and here, between these two, how many standard deviations can we stuff in there? I mean, how many standard deviations will fit in there? So how many SDs fit in that interval? That's what we want to know, okay? And that becomes our metric. In other words, what a z gives us, it gives us the number of standard deviations that we're able to fit between those two. So z is equal to x minus mu, the difference between our observed point and the mean, divided by the standard deviation, and that gives us back the number of standard deviations that x fell above or below mu. That's an x there, actually. There we go, looks more like an x. Either above or below, depending on whether the sign of z is going to determine that. Okay, mu for the mean. All right, so let's go back to our page here. So a couple of quick things down here. So if we're working in this particular chapter on the normal distribution. Think about z-scores is they work independent of any distribution. They're not it doesn't require to be a normal distribution to calculate a z-score. It still will give you the position above or below the mean in units of standard deviation. Okay, so if your mean is right here, which it will be in a standard normal distribution, or if that many, any normal distribution, because it's bell-shaped unimodal, if you have a negative z-score, then that means your observed value x fell below the mean. If you have a positive z-score, again, okay, so right down here, that's mu again, and then this point over here, that's x. If you have a positive z-score, then that means that your x fell above the mean. Okay, well, with that little bit of review, hopefully all that sounds real familiar because you guys did read the book, right? Let's get on to exercise 3.3. So we're going to get over to RStudio for that because I've already gone in and preloaded that exercise into the RMD that we were working on in part 1. And we get to here in part 2, we're going to start working on exercise 3.3, which says scores on a GRE. Part 1 of that, we're going to actually do two problems, 3.3 and 3.5, both have to do with this scenario. So a college senior who took the graduate record exam scored 620 on verbal reasoning and 670 on quantitative reasoning. The mean score for the verbal reasoning was 462 with an SD of 119. The mean for the quantitative reasoning was 584 with an SD of 151. Assume both distributions are nearly normal. So for these folks who don't know, the graduate record exam, you can think about it as sort of analogous for when you finish your bachelor's degree. If you want to go on to graduate school, It's kind of like taking the SAT again, one more time, but even more intense to decide whether or not they're going to accept you into the particular grads program that you want to get into. All right, anyway, so what they want us to do, the first one is use our shorthand notation for normal distributions for these two. So let's say we'll put VR for verbal, okay? So that's going to be, I'll put an arrow in there. So the verbal reasoning normal distribution, that was the first one they gave us here. And we had a, let's take a look at the mean score. For verbal reasoning was 426. So it's going to be N, it's going to be 462. N of 462 for our mean, and a standard deviation of 119. Okay, so I'll put a comma here. Oh, by the way, I want to go back up to my previous line just to make sure. RStudio, the markdowns files, to get a line break, they'll kind of flow into each other unless you put a double space at the end of your line. So if you want to keep your lines from running into each other, put a double space at the end of them. Again, if you need to remind yourself any of that, remember we've always got the Markdown quick reference guide that you can have over here, manual line breaks, and the line with 2 or more spaces. Okay, so just a reminder of that. All right, so back here, so we got what else? We got QR for quantitative reasoning, and the quantitative reasoning, that again was a normal distribution, but this time it had the mean for score for there was 584, and the SD was 151. Okay, so if you go back to our intrepid student here, just looking at the raw scores, you might be, unwittingly duped into thinking that she did better on her, let's see, she got a 620 on her verbal reasoning and a 720 on a quantitative reasoning. So you might think, just looking at the raw scores, that she did better on the verbal reasoning than she did on the quantitative reasoning, okay? So let's go take a look and find out if that's true or not, all right? And the way you do that is by looking at z-scores. You don't just look at raw scores because you're trying to compare, in this case, how she did with relative to the other takers of the test. When you take the GRE, they give you back where you fell, what your percentile was compared to the rest of your peers on your particular score, okay? So they say draw a standard normal curve distribution and mark these two z-scores. So first they say, what is her z-score on the verbal reasoning and on the quantitative reasoning, and then draw a standard model distribution to give those two. All right, well, we can do these by hand, which I think I'm going to go ahead and do that simply because it's good to get some practice doing those. But of course, we can also insert a chunk and actually get R to do the calculation for us. So we'll do both, okay? So I'm going to come over here and open an R chunk. And let's go back for a moment to the whiteboard real quick and take a look and remind ourselves how we actually do these, okay? So let's get a fresh whiteboard here. Go ahead and clean this one up. So how do we actually calculate a z-score? Well, remember that z is equal to x minus mu divided by sigma, okay? So in the case of the verbal reasoning, that tells us that what? Well, she scored a 620, so that's going to be a 620 minus the mean, which was 462, divided by the standard deviation, which was 119. And then on the quantitative reasoning, she scored a 670, and subtract that the mean of 584, and I'm going to divide that by the standard deviation of 151. Okay, so notice this notation, the way I wrote this down. This is called inline notation. I'm not using the long fraction bar like is in the formula up here. Notice up here I've got this long fraction bar. We're going to be careful with this thing. This thing is actually a no good rotten dog meat, okay, because it's doing double duty. Not only is it inferring division, but it is also inferring a grouping symbol. Well, on RStudio or my calculator, I have to infer division, I have the backslash. And so in order to get the backslash to work appropriately, I have to put in those inferred grouping symbols explicitly. In other words, I need to put the numerators in parentheses, okay? So, excuse me. So make sure when you're getting rid of this bad boy right here. In other words, when you're getting rid of that fraction bar, that you know that you have to put in explicitly the grouping symbol that was tacit in that fraction bar. Okay, so let's go back to our R chunk now, and let's go ahead and type those in, okay? So back over here to RStudio, and let's go ahead and put in the 2 here. So we're going to put in, type in just how I had them there. So 620 minus 462, and then divide that by 119. Of course, you could do this on your calculator also if you wanted to. But since we're going to have to type it up in RStudio anyway to put our answer in here, might as well let it do the work for us, right? Oops, my parenthesis in there. So 670 minus 584, and then divide that by 151. Okay, and now as usual, we can go in and execute just that chunk so we can see what is going on. So we'll run the current chunk, and we get the 2 Intrepid z-scores here. So let's come down and put in here. So for the verbal reasoning, that's a her there really, her z-score was what? Well, it was 1.328. We'll go out 3 places. That's plenty. And for the quantitative reasoning, her z-score was, let's see, what was it? It was 0.570 if we round off to 3 places, okay? All right, so which one did she do better on? I just want to think about this for a minute. That's going to come up here in a question. But at first, like we said, we might have inferred, since the larger of the 2 scores was the quantitative reasoning one, the 670. But if you take a look at her z-score, the larger z-score was actually in her verbal reasoning, not in her quantitative reasoning. So they ask us to plot these on a normal distribution. The hand-drawn stuff you do not need to turn in, okay? But I still want you to do it. So you don't need to put it into your R Markdown file. You can get R Markdown to do what I'm about to do, but the amount of code to get it to do it is not worth it. So just sketching it by hand, and I'll trust you that you did it, okay? All right, so let's go back over to the whiteboard for just a moment here, and let's go ahead and put in our numbers here. And then we'll put in, me of very little memory. So let's see, what are 2 numbers? They are, let's see, 1.38. So 1.378. And then let's see, what do we got for? It's 0.570. Okay. All right, now they ask us to take and put these on the 2 distributions, okay? In other words, they want us to come in and basically draw the distribution of verbal reasonings. So this is our verbal reasoning distribution here, and we know that it's a normal distribution with a mean. Ooh, I have an inco there, don't I? I wrote down 46, and I meant to write 462. There's a 2 in there, really. So in the verbal reasoning, we know that the mean here was 462. And the standard deviation was 119. So that's back from part A there. That's what the model looks like. And so that means that the mean right here is at 462. And we know that 1 standard deviation above or below the mean happened at the inflection points on our distribution. So her z-score was 1.378. So that means that the 620 is going to fall roughly about there. Okay, so that's about where she fell with respect to her distribution. And we know that the distance from there to there in units of standard deviation was 1.378 standard deviations above the mean, okay? So in other words, we know that the z here was equal to 1.378. Okay, so let's take a look at the quantitative reasoning. So under quantitative reasoning, if we were to make a sketch with that, so we know that this is again a normal distribution with a mean of 584 and a standard deviation of 151. So the mean right here is at 584. Her score was a 670, and we notice that that's half a standard deviation above the mean. That's 1 over to there. So her score would be roughly right about there is where the 670 falls in this distribution, okay? All right, so as we can see, I mean, roughly these distributions are obviously different shape, but we can see that her verbal reasoning score fell higher in the distribution than her quantitative reasoning did when compared to her peers, okay? All right, so let's go back to our studio here, and it says, what do these z-scores tell you? Okay, so that one is just pretty much a canned answer here. It's just they give they give the number of standard deviations above the mean. That's all they're looking for there. They weren't looking for anything more glorious than that, all right? Okay. And then in part D, they say relative to each other, which section did she do better on? Okay, well, we've kind of beaten a dead horse here, but we know she did better on the quantitative reasoning. She did better than that on the quantitative reasoning part of the exam, okay? So find her percentile scores for the 2 exams, okay? So what do we mean by that? All right, well, this time we're going to insert in our chunk because we're going to have to go do a p-norm. So I'll go insert a chunk here and get ready to go. So what do we mean by that, okay? Well, I mentioned this on the previous one. It's something to keep in mind is that when we talk about percentages, probabilities, proportions, every one of those goes with p-norm, all right? And if you forgot how to use p-norm, again, you'd simply put in a question mark p-norm. Should be in your comp book what that command is, and it'll give you a little cheat sheet over here to explain to you how to use it. So the first thing you put in is the cutoff point, then you put in the mean, and you put in the standard deviation, and it will give you back the probability that you're looking for down here in the p-norm, all right? So they want to know the percentile for the 2 exams. So before I actually go and type this in, we need to go do our drawing. You never do a p-norm without first going through and actually doing the drawing. Now, when they're asking for the percentile, let's go ahead. I'm going to just modify my drawings here just a bit because I've already done them. I'm going to get this z out of here. That was kind of a goober there. Okay, so when they ask you for the percentiles, what they're asking you for is what percentage of folks fell below them. I mean, what percent were they at? So when you get back your GRE score, one of the things they give you is your percentile. So they say, well, if you fell in the 77th percentile, that means 77% of the people fell below you. So to calculate those numbers, what I need to do is find the area below my particular score. So in other words, I need to find these shaded regions here. So this shaded region down here will correspond to the percentile of people who scored less than 620, okay? And then similarly down here in the quantitative reasoning distribution, this shaded region right here will correspond to the percentage of folks who scored less than 670, okay? All right, so let's go ahead and do that. So in this case, what I want to know what is the proportion of the x's that is less than 620. Well, notice since it's a less than, since it's a left tail, I'm not going to have to do that 1 minus thing. I just need to go p-norm, give it the cutoff score, which is 620, give it the mean, which is 462. There's a 6 in there, really. Sorry, you guys, this is a little messy, but I'm sure, hopefully sure it's making sense. Here, I have an eraser. Let's go clean it up a little bit here. Let's make that 462. There we go. Okay, great. 462. Yes, I should have been a doctor. I've got doctor's handwriting. Okay, so let's go ahead and enter that one in first. So let's go back over to our studio. And so for the verbal reasoning, we're going to put in p-norm. Oops, get myself in the right spot here. On the console, I want to be up in the actual R chunk. So put in P norm, and then let's see, my cutoff score. Let's see, what was it again? We're going to do 620 by 462 by 119. Okay, and then we'll do this one more time. And we're going to go 670. This is for the quantitative reasoning, by 584 by 151. Okay, let's run that chunk and take a look and see what those numbers are. Okay, and we get so that in the first case, she did quite well with that 620, right? She got in the 91st percentile. That's what that tells us. So she scored really well on the verbal reasoning, and she didn't do bad at all in the quantitative reasoning either. She got in the 72 percentile. Okay, so that's the work. We should come down and actually answer the question. And should we sit down here, say, okay, in verbal reasoning, her percentile was, because we want to give that back as a percentage, and we're going to say 91%, okay? Or you can say she was in the 91st percentile, and in the quantitative reasoning, she was in the, 72nd percentile. Okay, good enough. That'll work, so as long as we understand what we're talking about here. Okay, so part F says, what percentage of the test takers did better than her on the verbal reasoning section, on the quantitative reasoning section? Okay, well, you could go in and recalculate those figures if you wanted to, or you could just do a little bit of arithmetic. So I think I'm going to do arithmetic, but I want to show you what they're talking about first. If you want to know how many of them scored better than her, let's go ahead and switch our color to blue here. Then what they're talking about is what's left up above her. So what percentage of the people scored higher than her? So it's these areas up here, isn't it, right? Okay, so probably the easiest way that we can get our studio to actually give us back that information. I mean, like I said, we could do some arithmetic, but if you want to actually have it in your document, okay, it's actually really easy. Just come back up here and steal the code from the previous R chunk. Or if you want, you can just go in and do 1 minus here also. And I'm going to put in those two here and just change it to 1 minus, because notice I'm getting what? The upper tails now? Does that make sense? Hopefully it does. Hopefully that's perfectly clear what's going on there. And so if I run the current chunk, notice that what I get is the area that was left. In other words, if I take 0.9078665 and add to that 0.092133348, I should get back 1. Similarly, the 0.7155 and the 0.284, add those together and I should get back 1. All right. So we can come down here and we can actually answer the question, and we can say it's one of the important things in this class is that you make sure you don't give just the numbers, you give their meanings also, that you actually report. There were what? Basically 0.9% or 0.09%, or excuse me, 0.09 or 9%. So there were 9% above her in the verbal reasoning. I'm going to abbreviate that. And there was what? 28% basically or in the quantitative reasoning. Okay. And I probably should spell that correctly. Okay, so explain why simply comparing her two raw scores from the two sections would lead to the incorrect conclusion, make those in one sentence, that she did better on the Okay, and the reasoning behind that is what we talked about at the beginning, is that you need to compare her to her peers there, right? And so you need to see relative to the other folks. So we need to use the z-score to see how far from the mean her scores were relative to her peers. You don't want to use the raw scores. Bad idea. Okay? All right, so if the distribution of scores on these exams are not nearly normal, so in other words, if they were like, say, skewed right, okay, would your answers for part B through F change? Explain your reasoning. Okay, well, so the same part A, what if we used a different model? What if we didn't use the normal model, right? So that's not going to change. So what would happen for parts B through F? Well, in part B, what we did is we calculated, let's scroll back up to remind ourselves what part B was. In part B, that's where we went and calculated the z-scores. So for part B, there'd be no change. No, why not? Well, because you can calculate a z-score for any distribution. It's not dependent upon it being normal. So z-scores work for any style distribution. For any shape. So for any shape distribution, that works, okay? But the remaining problems were calculated using a normal distribution. So no can do. You can't use the normal distribution for calculating the rest of those. All right, well, hopefully this is making total sense to you, and you're having as much fun with this as I am, and I'm going to see you back here for the next one, okay?